Hello and welcome to this video. I'm going to be going through the OCR GCSE Computer Science Sample Question Paper 2. So the sample paper for the second component of this course, which is the more practical programming paper of the two. So paper 1 more theory, paper 2 more programming theory, but more programming practice as well. Now, because this is a sample paper, nobody's actually sat it for real, meaning there are not things like grade boundaries to compare marks to, which is unfortunate. And because it is a sample, if you're watching this fairly close to when I've uploaded it, I would massively recommend you actually doing this paper yourself, sitting down in exam conditions and trying it once you are comfortable with the theory needed for this paper. I say that because there aren't many alternatives you can practice. If you're watching this 5 years down the line, that's fine, watch it. Don't need to practice this one because you've got more papers available to you. Now, in terms of what I'm going to be doing, I'm going to be going through and answering these questions as if I was doing it for real, but just narrating what I'm thinking out loud. I haven't seen the mark scheme yet. I'll check that what I've written is correct before uploading. So that's what I'm going to be doing along the way. Now, in terms of sort of the admin for this paper, always good to know going in, you can't have a calculator, so don't bring one into the exam. The maths won't be very tricky at all in this paper. No binary, it's just programming, and not the binary is tricky maths anyway. Like paper 1, it's out of 80 marks, and also like paper 1, it's 1 hour, 30 minutes long. So basic exam technique, you've got 90 minutes to do this exam, and you've got 80 marks to do it in. So it means if you spend a minute a mark, you've got 10 minutes to check at the end. In an ideal world. In reality, some questions will take longer than the number of marks allocated, others will be really quick to do. And I would say if you are concerned about running out of time, do this paper in exam conditions to actually see how you are getting along. Right, if you're doing a paper for the first time in a real exam, you'll have no real idea how to pace yourself. Okay, let's get started with question 1. Now, section A is where it's really a mix of different questions from the spec and different topics, but for code you're writing, it doesn't have to be specifically a language like Python or the reference language. So we'll come on to talk more about that later on in section B. But for now, we've got a question on Boolean logic. So we've got to complete the truth table for the Boolean statement P equals not A and B. Well, if you've got stuff in brackets, that means you do that first. A and B, Boolean AND means both sides have got to be true for it to be true. So both sides have got to be 1, in other words, and not just flips it around. So when A is 0 and B is 0, 0 and 0 is 0, but not makes it a 1 as it's filled in for us. When it's 0 and 1, that's going to be 0, but it flips because of not and becomes a 1. 1 and 0 is 0, but again it flips to become a 1. So the two answers there are just 1, 1. For part B, we need to tick one box to identify the correct logic diagram for P equals not A and B, what we just did. Now, in terms of our symbols, this one here is OR, this one here is not, and this one here is AND. And so therefore this rules out the first one. The second one, we've got AND coming first, and I said what we do within the brackets comes first, like in maths, and so therefore this must be correct because I've got AND coming first, followed by not. So let me tick this box. This one here, we're notting both inputs, then doing AND, that's not correct. Okay, now a bit of code for question 2. We've got a program which needs to perform the following tasks. Input 2 numbers from the user, compare both numbers and output the largest number. And we've got to complete the pseudocode for this program. Now, but when it says pseudocode or doesn't specify something like a programming language, how you answer it is not super important. For these fill in the gap questions, my strong recommendation is copying the pattern. So the first bullet point is inputting 2 numbers, meaning this first gap is also an input because you could sort of spot the difference. Now you could, deviate completely from how it's done it below, but why? Keep it consistent is my strong advice. So we've got num2, it said enter second number, so therefore let me just fill in the top one, which I'm going to do the exact same, but this one's going to be enter first number. And now we're looking to do our comparison. We've got the inputs down. So comparison in programming is an if statement. So it's going to be if num1 is bigger than something. Well, I've only got num1 and num2 to play with, so therefore that's going to be num2. Then what am I going to do? Well, it says output the largest number. And so therefore, if num1 is bigger than num2, num1 is the largest, so I can just output num1. Again, I'm kind of following the convention. You could do print here, not super important with pseudocode, but I'm doing it lowercase, brackets, and so on. One thing I'd say is important is don't stick quotes around variables. Num1, num2 are variables. Quotes are put around data which is a string. So a word, if you wanted to print out just num1, you'd put quotes around it, but the variable has no quotes. Then I've got an else clause. So what happens if this isn't true? Else runs if the if statement wasn't true. Well, that means num1 is smaller than num2. So in this case, I'm going to output the other result, which is num2 being bigger. And if you did things a little bit different here, like use print instead of output, or uppercase if, or so on, that would be fine. It's just when you deviate completely, it looks a little bit odd, in my opinion. Now, we've got a second program which performs the following tasks. Input a number from the user, double the number input and print the result. Repeat bullets 1 and 2 until the user enters a number less than 0. And it says write an algorithm for this program. How many marks is this one worth? 5 marks, okay. Now, again, it doesn't specify what to write it in. When it says write, I would not use a flowchart personally, but you could just do this as written English, although I would always suggest doing it in code. Right, so the first thing you need to do is input a number from the user. So let's ask the user for a number. We could just copy the way it's done above. Num equals input, enter a number. So these have quotes around it, this text, because it is a string and not a variable. And I want to double the number input and print the result, but I could do that here, but really I'm looking to repeat it until the user enters a number less than 0. Now this last bit, until the user enters a number less than 0, that could take them 1 try, it could take them 5 tries, it could take them 1,000,000 tries. And so what I'm looking for here is an indefinite loop. An indefinite loop. So not a for loop. A for loop is a definite loop. It loops a set number of times. We're looking for it to loop until a condition is met or broken, which gives only 2 options. We've got either a while loop, or we've got a do while loop, or a repeat until loop. They're the same thing effectively. Now, I know Python, so I'm going to use a while loop. A do while loop doesn't exist in Python. So if I go here, a while num is, what does it say? We're going until the user enters a number less than 0. So while num is greater than or equal to 0, we're going to keep repeating and keep asking. As soon as it becomes less than 0, we stop. So what does it say? My second bullet point says to double the number input and print the result. So I could just here print num times 2. Using the asterisk there as multiplication, you could just do a times in pseudocode, that's okay. Now, I'm not done, because this loop would go on forever. You've got to give the user a chance to enter another number, because otherwise that condition would never, ever, ever become false, meaning it loops forever. So I'm just going to repeat the exact same line I started this algorithm with. Okay, so I guess the main thing that's getting you 5 marks here is your ability to use a loop and realizing it's a while loop and not a for loop. If it said it's going to repeat 5 times or 10 times, it would be a for loop. Otherwise, use a while loop or a do while loop. And again, like the question above, if you're doing things a little bit differently, that's not necessarily a problem, because it doesn't specify to put it in a particular language or format. Now we've got a question on databases. So we've got the database table called results, which stores the results for each student in each of their chosen subjects. We've got 3 fields: student name, subject and grade. A field is a column in a table. And we've got 5 records. A record is a row in a table. So we need to complete the SQL query to return all of the fields for the students who take art. And it has helpfully given us each of the clauses: select, from and where. There's also another one called order by, which you might need to know, so don't forget that one in case it comes up in your real exam. Now select, the first part of this whole select statement is saying which fields you need to get, and it says to return all of the fields. So what you could do, you could write down the field names. So I've got select student name, that's one word, comma, subject, comma, grade. I could do that. I'm saying could because actually there's a quicker way. In SQL, there is a nice symbol which is called a wildcard, and it represents everything. So if I put down instead a asterisk, that represents all. So asterisk means all. So I can just go select star and that's fine. From is where we write down the table name. So the table is called results. And where is what you use to narrow down your search. So we're looking for just students who take art. And so I'm going to say where subject is the field name equals art. And a bit like before, you put quotes around the values, the string, not the name of a field, which is a bit like a variable in this case. So this would only give us the fields of people who study art, so only Jackson, Alex, and Ishmael. Right, let's move on. We've got a flowchart with a program which creates usernames for a school, and we've got it all the way down here. Let's zoom out a little bit. Okay, now, for example, using a process in this flowchart, Tom Ward's username would be Tom Ware. I mean, to state using this flowchart, the username for Rebecca Ellis for only 1 mark. So let's go through this one by one. Don't just guess it. Make sure you follow the algorithm if it gives you one. So first of all, Rebecca's going to start inputting her first name. Let's write down Rebecca. Then input the surname, which is Ellis with, is it 2 L's? Yeah, 2 L's. Now we've got a process box which is setting name to be the first 3 letters of first name, which is R-E-B. So name equals R-E-B. Could do that in quotes. Username is now what name is, so R-E-B, plus the first 2 letters of the surname. So username, and look, you wouldn't write this out in a real exam, I'm just doing it for the sake of it. It's only 1 mark this question. Username equals Reb plus 2 letters of surname, which is E and L. So you are concatenating these, that's when you add 2 strings together. Then we output username, so this is going to be Reb L, like that. The plus just puts the 2 strings together, no space, it should be all 1 word, like the example was. Okay, now for part B, the program design is updated to create usernames as followed. If the person is a teacher, the username is the last 3 letters of their surname and then the first 2 letters of their first name. Whereas if the person is a student, the username is the first 3 letters of their first name, not the surname, and then the first 2 letters of their surname. So flipped around, whether it's a teacher or a student. Now, BI, what would be the username for a teacher called Fred Biscuit using the updated process? Well, Fred Biscuit is a teacher, so we're looking at this first bullet point. So last 3 letters of their surname, which is U-I-T, followed by the first 2 letters of their first name, which is F-R. So that would be their username. And for II, we need to write an algorithm for the updated process as talked about. Again, the exact format here is not specified. I would always lean more towards doing code, unless you really can't and are going to really find it hard. I would always go for either Python code or pseudocode. Now, you can be a little bit more relaxed if it was Python code, say, because it's not saying do it in a programming language. Now, what do we need when we're doing this algorithm? First of all, we need to know their first name and their last name, no matter if they are a teacher or a student. So let's ask them for their first name and last name. Okay, I've just done it as a Python statement there. Now, one thing I would say is I did it in the previous questions because it had an example with it in, but in terms of writing text inside input, I would not write long messages in exam questions. You could be like, welcome to my program, what is your first name, what is your last name? You could be really polite and really formal, but it's an exam, just focus on the code, not the messages. That's not as important. Unless it says, ask the user for their first name and last name. Now, I also need to know if a user is a teacher or a student. So let's do that as well. So let me go, let's go type, for want of a better word. And now I need to decide what to do based on if they are a teacher or a student. So I want to use an if statement here. An if statement selects what to do. It's if type equals equals, that's how you do it in Python. Teacher, we're going to do one thing, otherwise we're going to do something else if they are not. Well, if they are a teacher, what are we going to do? We are going to get the last 3 letters of their surname. So let's set the username. Let's make that a thinner pen. Let's set the username to be the first 3, sorry, no, that's not right. The last 3 letters of their surname. And how you do this could depend. Let me do the Python version first before doing the OCR reference language version. So username equals last. In Python, you can use string slicing, which you might have used. And you can do something like this. You can go last -3 colon close bracket. I'm using square brackets because really we're indexing the string. What this does, if I have, say, let's do Fred Biscuit again. If I have Biscuit as my surname, Python has a neat thing called reverse indexing or negative indexing. So this first B would have index 0, then 1, then 2, and so on. But I can equally start counting the other way around. I can have T being -1, then we've got -2, -3, and so on and so on. So me going -3 colon bracket, I'm starting at -3 and continuing on to the end. That's how the Python code works. So I get the last 3 digits fairly easily, if you've learnt that at least. Then likewise, if I want to get, what was it, the first 2 of the first name, so that's a plus, I'm concatenating, first bracket, I can do colon and then 2. That gives me the first 2. So again, if I do it with Fred, F is index 0, then 1, 2, 3. When I go colon to 2, the way Python works is it starts at 0, then gets 1, and stops just before 2. So in Python, it doesn't include that second number. The second number in slicing is not included. So we just get F and R in that case. Now, if that's confusing, I'll show you maybe an easy alternative in a second, but that's personally what I would do. And then that's the username for a teacher. So let's do an else clause. So if the if statement wasn't correct, if they were not a teacher, let's assume they are a student. And so I do a similar process, just flipped around for the student. Although it's not quite the same, I realised as I was writing. So I almost misread the question there, like it's subtly different. To help you avoid doing what I almost just did, a good technique is highlighting as you're reading. So you can maybe highlight the key information as you're reading. If you notice a difference between, say, surname and first and last, you might want to do a little kind of exclamation mark to warn you for later on as you're reading. Just a tip, wouldn't work for everyone, I imagine. Now, final thing to do is output this final username, which I could have done inside if and inside else, but it's not super efficient. I might as well do it right at the end and just print username. Now, as I've said a couple of times, if you made that a little bit more relaxed, if you did it more in just structured English, that would be sufficient for this question, but this is a very safe way to get full marks. I did mention there's a slightly maybe easier way to do the slicing and getting a substring is what this is called. So in the OCR exam reference language, they mention a couple of methods which could be used in questions. So you could go, say, last dot right and put a 3 in the brackets, and that's the same as doing what I've just done down there. Likewise, first, you can do, say, first dot left and put a 2. That gives you the first 2 characters. So you might find that simpler. And moving on to question 5, we've got a computer game which we're told is written in a high-level programming language. State why the computer needs to translate the code before it is executed. So high level refers to the fact that it's very abstracted, it's very separate from what is going on behind the scenes, I suppose. Right, this code I've written here is Python code. It's not as straightforward as written English, but we've got English words, we've got symbols. It's relatively understandable for us. The computer can't execute this directly, it's got to execute binary only. So you've got to convert from high level all the way down to low level, and in particular machine code. Machine code is the binary equivalent of the high level program. So let me say the CPU, which is the processor, can only execute machine code. And to be really clear that I know what I'm talking about, I might say which is in binary form. It's not quite a misconception, it would make me a little bit cringe. Is an answer saying something along the lines of the computer can only understand binary. The word understand I'm not a big fan of in this context. I mean, I'm sure I've said that at some point. Like, it doesn't really understand it, of course. You might want to say it can interpret it, it can execute it. Understand, it doesn't actually understand it, it can just follow it. Okay, and now there are 2 types of translator that actually take this high level code and put it into binary: compiler and an interpreter. We need to describe 2 differences between how a compiler and an interpreter would translate the code. So what would they do differently? Well, let's use this previous code as an example of how they would approach it. Right, a compiler, if I do a compiler in green, say, a compiler will go through and translate all of the code to binary and will produce a file like a .exe file called an executable. And to actually run the code, you double click the .exe file and it runs. So it translates it all in one go and puts it into an executable file. Whereas a interpreter, if I do it in black, will look at a line, execute it, look at a line, execute it, look at a line, execute. When I say look at, I mean translate. It will translate a line, execute it, and so on. It does it line by line until the program has ended. Now, if you want to run the code again, you've got to start the whole thing again and redo every line. It doesn't actually produce anything at the end which you can execute. So that's the key difference in terms of how they work. In terms of the result, if you wanted to hide your source code, you'd use a compiler because you just get left with a binary executable. An interpreter, you have to actually send your source code along with your translator. But it does mention how they work, not the sort of end result or the use of it in real life. So let's write up what I just said. It's 4 marks here, so be really clear about the difference. Don't just say a compiler does it all in one go. Make sure you then contrast that to an interpreter. But I will start by saying a compiler does it all in one go. Whereas, which is a great word to use for these differences questions, whereas an interpreter will just translate it one line at a time. And as a second difference, let's mention that executable aspect. So once the compiler finishes translation, it will produce a file which can be executed. Whereas, really I've said this before, but whereas the interpreter will execute it while it is translating. Okay, so I would suspect a lot of people would get 2 marks here just because they didn't really fully compare the difference. In terms of what else you could write, you could also mention how they handle errors. So a compiler, if it comes across, a compiler will finish compiling the entire program, then you run it, and if you have an error, it won't run. so they don't get an error message straight away. Whereas an interpreter, once it hits an error, it stops for translation. So that's how they handle errors a bit differently. If you were brave, you could also mention optimization. So a compiler is able to optimize a lot more easily. Because a compiler can look at the entire code all in one go, it can do some clever efficiency boosting measures. Whereas an interpreter, because it's looking at one line at a time, can't really see the bigger picture and can't really optimize as easily. So a compiler is kind of faster in that way. For the next question, question 6, we are told there's a program using a file to store a list of words that can be used in a game, and we're given this list here. So they are words, not numbers. I say that because we're having to apply a bubble sort to this list. If they were numbers, it would be a little bit easier because it's just easier to sort in your head. Whereas letters, you've got to look at the first letter of these words and think about where it sits in the alphabet. Now, you may judge me for this, but the first thing I would do in something like this is write down the alphabet, because you don't want to make a silly mistake getting the order wrong. Right, so the way bubble sort works is it goes through the list and swaps the pairs when they are out of order, which, again, not a great question, because you have to write out each word. In this case, if it's a number, it's much more simple. So, first of all, crime and bait, well, B is before C, so we're going to swap these two words. So bait comes first, then crime. Now, we are not given lots of space here. Bubble sort generally, well, obviously needs quite a lot of swaps, but it takes a few goes. It takes a few what are called passes. It might take several passes to actually get the list sorted. So if you write down every single step, so what I could do now, I could copy fright, victory, nibble, loose, then start again and start again and start again. That's still only one pass. So given the amount of space we have been left here, I would personally only write down when you're making a change, and I'll try and combine the steps in this process. So, bait and crime. Now looking at crime and fright would be the next two to swap. C is before F, so we can leave it like that. Then looking at fright and victory, F is before V, so we can leave it like that. So let's write down fright. Then looking at victory and nibble, N is before V, so therefore nibble should come before victory. Then I've got victory and loose. Well, V comes after L, so therefore loose goes there. Then you have victory. So I almost lost track of what I was doing there because I'm skipping steps. You might write down this in more detail, but I'm just looking at the space here. I think it's not very worth it. So that is one pass, and you might want to jot that down. I mean, to be honest, I'd be tempted to do this in pencil, but full stop, but at least at first, because little mistakes might be fairly easy. So my second pass, well, bait and crime are fine, but then crime and fright, C is before F, so that's okay. So let me copy down these again. And then fright and nibble are also fine, but L comes before N. So I need to put loose before nibble, and then victory is going to stay where it is, because the way bubble sort works is the items bubble towards the end, so the biggest one is going to come last, so that's the same. Likewise, nibble is now in the correct position as well, so that's pass number, I forgot to write 2, pass number 2, now pass number 3. Bait, crime are fine, so is crime and fright. Now fright and loose is okay, nibble and loose is okay, and therefore we are done. So that last pass made no changes, but that means the list is sorted. Now, if you were really wanting to play safe, you could add in more stages, and maybe, circle the items as you're looking at them. But I think especially if you're writing down the pass numbers, it shows your understanding how this works, and so that should be sufficient. Just on that last point, just to emphasize what I think I just said, I wasn't really listening to myself, the idea that you've got to do a final pass, otherwise you're not sure if it has fully been sorted. So often there'll be a question like, why is it done a third pass, not just 2? and it's because it's got to check they are fully sorted before it can finish. Right, part B looks like a very similar question, this time doing binary search on a different data set. Binary search only works on sorted data, so it can apply to this original list. Now, we're trying to find the target item zebra. Using this data, zebra is right at the end. And so binary search, the whole idea of it is, as the word binary in it suggests, you keep dividing by 2, eliminating the half of the list as you go through. Because it's sorted, you can easily eliminate anything which comes before your target item, or equally anything that comes after it. So we start by looking at a midpoint, often called a pivot. So the pivot or midpoint. The first pivot is going to be our middle item, which is going to be orange. So orange is our middle item. And we're comparing zebra to orange, which sounds very stupid, but that's what we're doing. So zebra is bigger than orange, at least in terms of the letter is a larger letter. Again, that sounds silly. It's further along with the alphabet. And so therefore what we're going to do is discard the left side. Okay, so effectively we are crossing out orange and anything below because it can't be there, assuming the list is sorted. Now my second pivot is going to be the midpoint of my my sublist. Here I haven't got a direct midpoint, so conventionally you pick either left of center or right of center. Now if you're being clever here, you can see zebras here, so I would definitely pick right of center here because it means you've got one fewer step. It's the slight trick to speed up things a little bit. So therefore wind is our next midpoint. Like I said, if you pick 10, that's fine as well, as long as you're consistent. And because zebra is bigger than wind still, at least in terms of its order, we're going to again discard left side. And finally, so that gets rid of wind, 10 and range. And finally, the last list is only one item, but we have got to fill in the steps. So the final pivot, pivot 3, is going to be zebra. And because zebra equals zebra, we can end the search. Now, the way I've written this out is how I would do it personally, obviously, but it's not a set way. I think really important you are clear what the midpoints is, what the pivots are, and what is going on in the algorithm at that point. For question 7, we are reminded that the area of a circle is calculated using the formula pi r squared, where pi is equal to 3.142 and r is the radius. We've got a program which allows the user to enter the radius of a circle as a whole number between 1 and 30, then outputs the area of the circle. And we need to, first of all at least, explain, using examples from the program, 2 ways to improve the maintainability of this program for 4 marks. So each of these points, I need 2 points to give me 4 marks in total. Now, maintainability is all about the future. It's all about you being able to look after and fix and extend the code in the future. A lot of code might work, but be badly written and be really hard to understand in the future. So we're looking for things which are going to make it more readable and easier to change down the line. Now, first thing which jumps out to me at least is the lack of indentation. In a language like Python, you've got to indent, but other languages don't have to, but it's a good idea because it makes things clearer. By that I mean, really, where my arrows are, we should have the line with a little gap at the start. That's the indentation. It tells you what belongs to what part. So for instance, it's sort of clear because you've got an endif, but are those part of the same block? Are they inside the else? I suspect they probably are, but it's not that clear. So that could be my first reason. Indentation could be added to the selection block. Then e.g. lines 7 and 8 are likely part of else, but might not be. For the next point, when you are given anything to do with pi, you should be on high alert about constants. A constant is a value which, once it's set, can't be changed. And pi is constant. Pi should always be the same. And Currently, we have it hard-coded to 3.142, which means if you wanted to get pi to a more accurate representation, if you wanted to add more decimal places, you'd have to change it here. Whereas it'd be better, ideally, to have pi defined right at the start as a constant, and it can be set at the top, so that if you change it in the future, make it more accurate maybe, it affects the entire program. You haven't got to go in and change it one by one. So let's say a constant could be used instead of hard coding pi. Hard coding is when you actually put a value and you set a value. It makes it harder to change it in the future, which is what I've just said, and also it reduces the likelihood of it being changed by mistake. Okay, now unless you are under incredible time pressure and you are really running out of time, after writing an answer to a question like this, I would look back at it and think, have I written enough to get 4 marks? For question 1, I'm not convinced I have fully explained it, but if I was in a real exam, I would probably not add to it because it's worth 2 marks, that part of this question, right? And I've said indentation, which is probably 1 mark. I've given an example, which is probably another mark. So probably me explaining it in more detail is possibly a waste of time. Whereas if that was, say, worth 3 marks, which is not, but if it was, I would need to explain why does having clearer code help maintainability? Well, it's because somebody looking at it in the future will need less time to understand it. They can find errors more quickly, etc., etc. So just check you've got all the marks available, especially if you find the question easy and you're aiming for these 8s and 9s. And part B is a nice question. Identify 2 variables used in the program. A variable we've used already today is where we have a name associated with a value. So name equals a value, that's a variable. A constant is a variable which can't change. So we haven't got any here, but pi would have been 1. So radius is 1, area is 1, and I think that's it, right? Radius and area. And CI, we've again talked about, so whoever wrote this paper, the sequencing is a little bit off. It's a sample after all. So we said, what could be written as a constant? 3.14, in fact, was it 3.142? Yeah, 3.142 could have been written as a constant, which is pi. Now, if you wrote down pi, as in pi here, you possibly would not get the mark because that's not in the code. It is what 3.14 is representing, but it's not actually in the code as pi. Now, the reason is this does not change, which, to be honest, there are other values which don't change. So this 2 doesn't change, 1 doesn't change, a 30 doesn't change. Those could be constants too. It wouldn't make as much sense as pi, but they could be constants if you really wanted to, but not pi as a written out word. For part D, tick 1 box in each row to identify whether each programming construct has been used or not used. So sequence is where we have lines executed 1 by 1. So do we have a few lines that go where there's no deviation? Yes, we do, here and here. We've got lines after each other without any deviation, so we do have selection. So give it a tick. Oops. Let's do that tick properly. I did it in a right-handed way by mistake. I should really do it how I normally do it. Selection is in the code. Let's have a look. Selection is if statements. So if, elif, else. We do have if, so therefore it's here. And the last one, iteration, there is no loop, so therefore it is not being used. Iteration, we're looking for while loops, for loops, and do while loops. An IDE is something like Eclipse or Visual Studio or Idle. The program you're writing the code in, we take them for granted because we could be writing code in Notepad with no help, but they provide some tools to us which can be helpful. Not all of them we use, but some are helpful. So for example, something like syntax highlighting is 1. Now, these are the colours you see. And that's not just because people are childish and like to see bright colours, but it's because it makes it easier to spot when things are off. If all strings are in green and one is not in green, you can see you've made a mistake. If all keywords go to orange, you can avoid using keywords because you know it's going to cause an error. So it is helpful. It doesn't say to explain it, but that's why. And we could also say things like a translator. So we have a built-in translator. Again, we could be writing code in something like Notepad and hooking up to a translator ourselves. Most IDEs have a built-in translator we can use to run our code. Other things include debugging tools, the text editor itself, error messages, etc., etc. Now for section B, where some questions force you to use either the exam reference language or a proper programming language that you have studied. This is where people start to drop down marks, I think, so make sure you have enough time at this stage. Don't spend too long in section A because section B is not much more important, but clearly is where there's less room for error when answering the algorithm questions for sure. If you can't write Python code or don't understand the exam reference language, difficult. So make sure you are ready for that. Okay, well, it's not difficult. It's his first question. So we have a teacher researching the length of time students play on computer games each day. We need to tick one box to identify what data type you would choose to store the data and explain why this is a suitable data type. Right, I wasn't really listening to what I said there. So the length of time is the main metric here. Well, length of time, probably best to do this as either an integer or a real string, so anything, but as a text. Boolean is either true or false. I'm going to say real. Real is where you have a fraction, also called a float in some languages. I think because you can use a real to get both, say, hours and minutes. Let's do that. Let's say with a fractional part to be even clearer. I think you probably could justify integer too. Just maybe the idea that actually minutes or seconds are less important, perhaps, but definitely not string or Boolean. Okay, let's move on. So part B, the program should only allow values from 0 to 300 inclusive as valid inputs. Inclusive means it should include 0 and 300. Exclusive would not include those two. If the data entered breaks this validation rule, an error message is displayed. Complete the following program to output invalid input if the data does not meet the validation rule. We must answer in either the exam reference language or a language you know. So you can answer it differently to me, but not in pseudocode here. Right, so mins equals input, enter minutes played. If mins is less than 0, something mins something, then something invalid input. Well, we're checking if it's between 0 and 300. So if min's less than 0, we're looking for, if it's outside of 0, we're checking if it is above 300 therefore. So let's add that in first, above 300 we're also checking for. The question is, and why I paused, because I was thinking about it myself, is whether you'd put or and here. Well, if we put and, that would be a mistake, right? Because it's not possible to be both less than 0 and greater than 300. So it's got to be or. It's one or the other. That's quite a common logic error, mixing up or and for conditions like this. And how are we going to tell the user it's a valid input? We're going to output it using something like print. Now, because it's got to be in the correct syntax, I really want to make clear that is a lowercase or, because in Python, which is the language I use to teach GCSE, that's a lowercase or not uppercase. Otherwise, that's all okay. You've got to be careful also with, less than or equal to. Because it's inclusive, we want 0 and 300, and so we can't have the equal sign as well. It's just greater than when it's invalid. Now we need to complete the following test plan for this program. A test plan is used to ensure you are testing your program under different circumstances, not just testing it when things are working, but trying to break it and see if it can respond. So 25 is within our range, and so is normal test data. And the value is accepted, which means it's working. Invalid test data is outside of this range. So invalid would be any number outside of this range. Let's go, say, 310. And this works as expected when we have our completed program. 300 is boundary because it's on the edge of being invalid. If it was one more, it would be invalid, but as it is valid, but it's on the boundary. If we say had a less than or equal to sign, that would mean that wouldn't work as it should do. So what happens here is it just says value accepted because it is valid, it's just on the boundary. For part C, we have data for 1 week, Monday to Friday, stored in a 2D array with identifier mins played. So the name of our 2D array is mins played, is what that means. And the table shows part of this array containing just 4 students. And the teacher wants to output the number of minutes Dan, column index 3, played computer games on Wednesday, row index 2. The following code is written, print mins played 3, 2. So a 2D array is an array within an array. And so we need to have 2 index numbers to access it. So what this is telling us is, and trying to help us out here a little bit, the first index number is our column, and the second index number is our row. And it's using a comma to separate them. In Python, for example, you'd have separate brackets, but not in OCR exam reference language. We need to write a line of code to output the number of minutes that Stuart played computer games on Friday. So we've got to copy this format for Stuart on Friday, not Dan on Wednesday. Let's copy the very first bit, which is just print mins played, because that's going to stay the same. What will change is the numbers we put in to these brackets. So if Dan is index 3, that means, as it says actually, we're starting counting from 0. So therefore Stuart is index 0. So we put 0 first of all, then a comma, and Friday is giving me index of 4. So we have 0, 4. That is fairly important. It does often tell you actually, but if it doesn't tell you, assume you start counting the indices from 0, because it's how it's done in most languages. Okay, now the teacher writes a program to add up and print out the total number of minutes student 2 played computer games over 5 days. Refine the program to be more efficient. We need to write the refined version of the algorithm. So yeah, not a very efficient way to do it. This person's just written the same code, or almost the same code, 5 times, when you could make it into a loop and really want a for loop here. If it's looping for 5 times, use a for loop which loops for 5 times, and just adjust the numbers each time. All you're adjusting is the row index. Because it's for student 2, the column index stays the same. Now the first and last line should be the same, because that's not the inefficient bit, it's the middle bit which shouldn't stay the same. So let's set total to be 0, because that's not a problem, and then use a for loop. Let me write this in Python because that's what I'm most familiar with, but if you obviously have done another language or want to use a reference language, that is fine as well. So the for loop in Python would be something like for I in range, and what are we starting with? We're starting with 0 and we're stopping when we reach 4, which in Python means, or in Python you should do, you put a 0 first, then a comma, and a bit like I was saying with string slicing earlier, the second number is always 1 bigger from where you want to go to. It stops just before it hits this second number. Then you do a colon, and now we are setting total to be total plus mins played. The only difference being I'm going to use I as my second index number, because what I is doing, I is starting at 0, and each time it loops 1 is added to I, so I becomes 1, I becomes 2, 3, 4 until it stops. So let's stick I as our second index. It's a variable, and that is doing what those 5 lines is doing. And finally, the final line is not a problem, but I've got to include it. I just print out total. This is how you might be done in exam reference language. You set the variable, I've called it x here, it doesn't matter what you call this variable, to be 0, then you go to 4, you have your cone of middle, then you have next x to trigger the next iteration. So I prefer the Python version, to be quite honest, but they do the same thing. Now for part A, we have a trace table. Some people really find these difficult. I've got a whole other video on trace tables. I think it's almost an hour long, very long, but I go into a lot more depth about how they work and techniques for solving them. Here we've got fairly short bit of code with a condition controlled loop. That's another way of describing an indefinite loop. So we've got a while loop, is what that means. And we must complete the trace table to test this program for 4 marks. Only got 3 things to keep track of: 2 variables, x and y, and the output of this program. The purpose of a trace table is to keep track of what is going on in your program. You need to act really dumb and just go through the code line by line, following it and writing down every time one of these columns changes. So starting at the top, x is set to 15. So I'm going to write down 15 in my first box. Then y is set to 0, and I could write down the 0 here and sort of go onto a new line every time. What I like to do is group my code. So because these 2 lines are at the top, I might as well put it on the same line, is my logic. Now while x is bigger than 0, I'm going to set y to be y plus 1. So this becomes 0 plus 1 is 1. And now x is becoming x minus y. So 15 minus 1 is 14. Again, these are in the same bit of code, so I'm going to group it on one line. Doesn't matter if you add a space, but you don't want to run out of space in your table ideally. Okay, going back to my condition. Well, x is still bigger than 0 by quite a long way. So now y is y plus 1, this becomes 2. X is x minus y, so 14 minus 2 is 12. Go back to my condition, x is still bigger than 0, so y becomes 3. 12 minus 3 is 9. Y is y plus 1, this becomes 4 now. 9 minus 4 is 5. 5 is still bigger than 0. 4 becomes 5. And now 5 minus 5 is 0. So we go back to the top. X is now not bigger than 0 because 0 is not bigger than 0. So therefore, this while loop has ended. And we go to the last line, print y, which means we're printing 5 on the screen. That's in a new bit of code in my head, so I'm putting it on a new line. But that is our completed trace table. So it just requires a lot of concentration to go through it, and please don't jump ahead. Don't try and predict what it's doing, because occasionally there'll be some tricks put in where you've got to follow it really, really carefully. For part F, we're told the teacher writes an algorithm to store the name of the game a student plays each night. For example, OCR Zoo Simulator. Sure, that is a riveting game. Now, it reminds us, it's not that different from the code, but it reminds us that variable.length gives us the number of characters in variable, so the equivalent of, say, len in Python, and variable.upper returns the number of characters in variable in uppercase, which is like dot upper in Python. So the code we'll look at in a second. Let's see what it's asking for. It needs testing to make sure the if-else statement works correctly. Identify 2 different pieces of test data that could be used to test different outputs of the algorithm. Give the output from a program for each piece of test data. It's pretty similar to a previous question on that test table. Again, sample papers are funny because they're not checked nearly as carefully as real papers. So you'll see, a few odd bits like that because it's been examined twice, that one bit of content. But anyway, I shouldn't complain. Before we can decide what test data to use, let's make sure we understand how the code works. So initially valid is set to false, while valid is false. It is going to ask for the game name, and what is it going to do? It's going to make sure it's bigger, it's not empty, but also less than 20. So between 0 and 20 characters. In fact, no, not quite. Between 1 and 19 characters, because it's not less than or equal to. Then it's going to set games played to be uppercase, set valid to be true, so the while loop will end, and print valid game name. If it's not the correct length, it will say game name is not valid and it will loop again. It's how this code works. Not the most efficient, but fine. So what test data would be good? We really want to see, does it work, does it not work? Let's try and enter something which is far too long. So let's say this is a long game name too long. Is that long enough? Let me just double check. 1, 2, 3, 4, 5, 6, 3. That's 33 characters by my count, so that would be outside of this range. So we should get game name is not valid outputted. And let's try one which is valid. So let's go OCR Zoo Simulator, which I assume is valid. Let's just check that one actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, just valid. So you should get valid game name outputted. So it's asking you here to actually think of something on the spot a little bit, but it's testing, are you thinking about how to test programs properly? You've got to test with both normal data and erroneous data or invalid data. That's really key. Okay, now the teacher asks students for how long they spend completing homework. They answer in minutes and hours. So for example, 2 hours, 15 minutes. We'd like to create an algorithm that will display students' input in minutes only. So converting from hours and minutes just to minutes. Identify the input and output required from this algorithm. So the input will need to be the number of minutes and the number of hours. And the input is what is being taken in by the algorithm, what it's going to work with. And it's going to give us the input in minutes only. So just the number of minutes. Okay, a fairly nice question at the end of this paper, or almost the end of the paper. And a program is made to convert hours and minutes into a total number of minutes. The teacher wants to create a sub-program to perform the calculation. It's been started but is not complete. We've got to complete the design for this program. Now OCR do a slightly weird thing where they put the function definitions after they do the main code, whereas in most languages, in fact I think every language I've learned, you put the definition above your main code so that you can call it later on. I'm not sure exactly the reasoning, but it just makes things more interesting, I suppose. So this is where you've got to write the code which is actually going to perform this conversion, and at the top is where you're going to call this subprogram. Right, a subprogram is a mini program which does one job and you call it whenever you need to use it. So it's a function, therefore we are expected to return something. So the last line should have return something. A procedure does not return a value, it just prints stuff. For example, a function gives you stuff back. Here it's going to be the number of minutes. And we've got to give the function a name. So let's call this one convert to mins. Like a variable, it must be one word. Don't let spaces creep into your names. And we need to have two parameters here, hours and minutes. A parameter is a variable used to input data properly to a subprogram. You could make these global and work on it globally. Bad design. It mentions design. We care about how you're doing things properly. And now, how do we actually do this? Well, let's set a variable called mins, and let's set this to be hours times 60, because you've got 60 minutes in an hour plus minutes. And that's going to give us our total. So now we can just return mins to our main program. So we do the calculation, return it. What that means is when we call it by writing the name and putting in our parameters or arguments as they are here, we are going to run the code in our subprogram, and once it finishes, it's going to give us minutes which get saved to final total. So this is where we are defining our subprogram. Once it's defined, we can call it in our main code using our parameters, and it eventually returns a value for us to use. Now moving on to our final question, which is a nice feeling. Well, it's nice for me, maybe not so much if you're in an exam situation and are stressed and are reaching the end of your paper with not much time left. I would say this is only 4 marks. In the past, the OCR programming paper has ended with usually a longer mark question, maybe an 8 marker, a 10 marker. We've got to write your own algorithm, so please bear that in mind. I have got a video on writing algorithm questions or how to answer algorithm questions, which can be tricky. This one looks not so bad because all we're doing is rewriting this flowchart as a program using either the exam reference language or the language you have studied. And as you've probably got a sense of, I would always recommend sticking to the programming language you have studied. I know not everyone's confident in what you have studied, but you learning a brand new language just for one exam, not sensible in my view. I mean, if you're going to get an 8 or a 9, please make sure you understand OCR's notation, but put more time into understand how Python works or the other language you have studied, because it is only for one exam. I'm happy OCR have made this and not just called it pseudocode, which is a slight lie. They've been quite clear that it is just a reference language, but something like Python you will hopefully use in the future. The exam reference language you will not. Now, don't let it put you off, because if you make a small mistake in Python, in your Python code, it probably won't get punished because they can't tell if it's exam reference language or the code you're writing. You've got to bear in mind the examiner might not know Python, might not know Java or whatever you've learned. So it doesn't need to be absolutely perfect, especially for only 4 marks. Right, so first of all, we need to enter the number of minutes played, which means we're going to have an input function assigned to a variable. So let's set minutes to be input. And I know I said not to do this right at the start, but I think because it says a message in the box, enter number of, let's just do mins played. Now I left a space at the start of the input function here, because if I'm doing it in Python, it's wanting a number, and all inputs by default are strings. And so one thing which people often forget is casting inputs to be a number. Specifically here, I reckon an integer. Could do a float as well, but you've got to cast it. Earlier on in the paper, when we were still doing just pseudocode, that wasn't important, but now it's actual code, we should have some casting going on. And now we've got a diamond. A diamond is a decision, which if it loops back, it's going to be a loop. But here, the arrows just go down towards end. There's no going back on itself. So therefore, it is an if statement. So if minutes is greater than 120, colon, what we're going to do, if it is greater than 120, we're going to say you played games for too long. A parallelogram is either input or output. When it says say, that's a clue that it's an output. So we're going to print, you played games for too long. Let's copy that one exactly, that message. If it gives you a message to output, make sure you write it down exactly. I've seen people be lazy and sort of rewrite it for no good reason. If it's not bigger than 120, we're going to say you are under your time limit. So let's add an else to this and say that alternative message. Now that's it. Quite a nice final question. I fear that you might find there's a longer one in your real paper, so please get ready for that. If programming is not your strong suit, you can revise this, I promise. If you are learning how to use if statements, learning how to use while loops, for loops, you can learn this even a few days before the exam. You know, if you have, say, an 8 marker or a 10 marker, if you only get, say, 60% of those marks, far better than nothing. If you leave a long question blank, that could be a killer in terms of your final grade. So try every question. There shouldn't be any questions left blank in a real exam. Have a guess if you're not sure. And ideally at this point, you'll have some time to go back over and check your answers. If you are sat there with, say, 10 minutes left or 20 minutes left, check every single word. Everyone will make a mistake. I'm sure I've made at least one mistake somewhere which I won't spot. You'll definitely make a mistake in your real exam because that's how exams go. If you can find it, hunt it down. You should be looking at every single question if you are able to. But anyway, hopefully this video has been helpful. If you have any questions, please do leave a comment, and I wish you all the best for your real exam.